Well, welcome to my channel, Mr. Sandin. Math with Mr. Sandin anyway. We're going to work with adding and subtracting rational expressions today. So the first example is here. I know that with regular fractions, without variables in them, you don't have to worry about having to make sure there are letters correct in the denominator, just that the denominators are the same. Well, and this is the same idea. The denominators are the same here, so we can go ahead and just add the numerators. 3a and 2a make 5a, because it's add between, over 25. Now we see if we can reduce. Well, the 5 can reduce with the 25. There's no addition in the numerator or denominator, so I can go ahead and reduce 5 and 1. My final answer here is a, or 1a, over 5. There you have it. Let's take a look at another example. In this one, we are subtracting, not adding, but it's the same idea. You have to have a common denominator. Now, this currently has a common denominator of b squared minus 9. So we can, first of all, we can think of it as b squared minus 9. And then, secondly, it's this minus this, not this minus just the first term. So make sure that you are distributing that term. I'm going to rewrite it down here just so we can see it. 4b minus 1 minus 14 plus b. The other way you could have done it is to have written 4b minus 1 and then put in parentheses 14 minus b and then distribute it. It's up to you. If you need to have that extra step so that you can really see where it's coming from, feel free to do so. Otherwise, feel free to do it as I have done here. All right. So now the next thing I'm going to do is do a little simplification. And 4b and 1b is 5b. Negative 1 and negative 14 is negative 15 over b squared minus 9. Once you have one polynomial on top and one on bottom, now we want to worry about whether or not we can reduce this. So I'm going to go ahead and try to reduce first. What do we have to do? Well, if you look back at your simplify, multiply, and divide sections, you remember we have to factor completely the top and the bottom, or numerator and denominator. So on top I can factor out a 5, and that leaves me with b minus 3. On the bottom, hopefully you remember that's difference of two squares. b plus 3 and b minus 3. Now it should be obvious that the b minus 3's cancel. And that's as far as we can go here. So our final answer is 5 over b plus 3. Whether it's in parentheses on the bottom or not is immaterial. All right, that is that problem. Let's take a look at another example. Now in all of these, you can always, if you think you're ready, pause and do the problem out, and then I do the problem out. That works great. All right, so when I look at this, we said common denominator. Well, I'm looking. I'm not seeing a common denominator currently, so I need to find a way to get a common denominator. Oh, this is just a little bit off. There we go, that's better. Hopefully it'll stay that way. So, I look at these denominators and I can see the common one would be 20. So you are welcome to just put one denominator, or you can rewrite it the way it's shown with separate denominators. I often like to just put one denominator, and the common denominator is 20 in this case. So, and then I rewrite with the numerators on top. For example, what do I have to multiply times 10 to get 20? I have to multiply, and it's not a good idea to use an x, right? So times 2, so I'm going to multiply the top times 2, that's 14x. Plus, what do I multiply times 20 to get 20? 1, or nothing. So that is just 3x. And finally over here, I have to multiply this by 4 on top and bottom, and it's a minus, so minus 4x. Now, if I combine all that together, 14x, negative 3x, and negative 4x, well, this, let's just do that. 17 minus 4 is 13x over 20. And there's no reducing possible, so we're done. All right, let's take a look at our next problem. Wow, that's a lot more complicated than the previous ones. And it's not obvious what the common denominator is. So if it's not obvious and it's got addition or subtraction involved in the denominator, I suggest you factor just the denominator. So I'm going to go through and factor, if possible, the denominators. In this one, I can pull out a 3 and get a plus 4. Here I can pull out a 6, a plus 4. Ooh, this is a nice thing. 5, a plus 4. All right. Well, if it's in one of the denominators, it has to be in the common denominator. Now you can write them as this, plus this, or you can make one big one like we did with the last one. I'm going to do it this way this time, but in general, I like to just write one big denominator. It's much easier. So it has to include a plus 4 as part of the common, because that's in at least one of them. It only has to be in at least one of them to be in the common. 3, 6, and 5. Smallest number that 3, 6, and 5 go into. Well, I think the smallest one would have to be 30. So 30, a plus 4, is going to have to be our common denominator. So again, you could do it, like this, where you have one denominator and just do the numerators on top. Or you can do it like this, where you have separate fractions with all the same denominator. It's the same idea. All right. What do I need to multiply times this to get this? Remember, these are done and replaced with what I've done in green here. It's just the same thing, just rewritten. So don't look at that previous one, you want to look at the green. I need to multiply by 10 to get this. So I have to multiply top and bottom by 10. That gives me 20a. Here I have to multiply top and bottom by 5. Gives me 25a. And here I have to multiply top and bottom by 6, which would give me 54. Okay. Let us combine over one denominator, because it's adding, right? So 30a plus 4, 20a, 25a, that's 45a, and 54. Okay. Well, that's good so far. Now I've got one fraction, and I have to simplify it if possible. It's not always possible, so we have to give it an attempt, though. Well, let's see. 9 definitely goes into the numerator, both of the parts. 9 times 5 and 9 times 6. All right, 9. Let's see, 5a plus 6. 30a plus 4. Well, it's obvious that these two are not going to reduce because there's no way to rearrange this by factoring to get this. So I can only reduce the 9 with the 30. 3 goes into 9 3 times and into 30 10. So I end up with 3, 5a plus 6, 10a plus 4. And leave it just like that. Don't distribute it back in. Much more work for both of us. Just leave it just like this. All done. All right, let's take a look at the next example. Oh, wow, that's quite complicated. So what you want to do, as we stated in the previous example, is factor the denominators and see what they have in common. In this case, y and y minus plus gives you a minus minus sign set up. And pairs of numbers that multiply to 18 add to 11, 9 and 2. All right, so now I've got it set up. Now if you want to, put parentheses around that to make it obvious for yourself. And now I'm going to just do one line this time. Now it has to, if it's in one of them, it has to be in the answer. I see y, minus 9. So I write it down. That's in this one and in this one. It's only in each of them once, so I only have to write it down once. If it were in the same denominator twice, you'd have to have it twice. Now I have a y minus 2. It's not in that one, but it is in this one, so it has to be down here. So now that we've done that, I can see that this doesn't need to be multiplied by anything to get this, so I can just write down the minus 9y minus 3. Now I'm going to do this in red so we can see the difference. Plus this one, now this needs a y minus 2. So I have to multiply the top by y minus 2 so that they have the same denominator. Now, I can do that by just rewriting it down here, or I can go ahead and distribute it, and as I distribute it, write it down here. It's up to you which you feel more comfortable with. You could just take y plus 3, y minus 2, and then later distribute it down here. I'm going to do it as I go. Y squared minus 2y plus 3y minus 6. Okay. Let's have a different color here. Okay. So now I'm going to do some combining of like terms. I've got my y squared descending order. I've got negative 9y, negative 2y, and positive 3y. That's negative 8y. Negative 3 and negative 6 make negative 9. That's what I have so far. Let's continue. I want to try to factor this into 2 parentheses. If it doesn't work, it doesn't work, and we just stop here. But I believe it will factor. A plus and a minus are our signs here, because a minus minus sign chart leads us to plus and minus. If this is negative, you know it's going to be a plus and minus if it's going to be anything. 9 and 1 differ by 8, so a negative 9, a positive 1. Now, if it's going to factor, the 9 had to be with the negative or it wouldn't reduce, I should say. I meant reduce, not factor. If it's going to reduce, it has to factor with the 9 with the negative anyway. So y minus 9, y minus 2. All right, let us see what we can do with this. What reduces the y minus 9s? All that I have left on top is y plus 1, and on bottom is y minus 2, and now I'm done. Now, all of these multiply, divide, simplify, add, and subtract, they are all leading us up to solving equations with expressions like these. And that's what we'll do tomorrow. All right, there's a big one. Maybe you can try that one on your own, and if you can do it, awesome. See what you can do. All right, I'm going to try it now. Again, always go through and factor the denominators if you can, if they're not the same, of course. In this one, there's no GCF, so I'm going to try to factor this. Now, these give you big hints as to where you're going. I know it's going to have to be a 3x and an x. I know the signs are going to be a plus and a minus. I'm going to try plus here first and minus just to see if the 3x plus 2 is our setup. Has to multiply to 10, so 2 and 5. Let's see if that worked. 3x squared, negative 10, 2 and negative 15 make negative 13. It did work. Now, I wanted x minus 5, not 5 minus x. So, do you remember how we changed the order of subtraction? Right. You have to factor out a negative 1. Now it's in the right order. All right, so here is the deal. If it's in one of the denominators, it's got to be in the common. I've got to include a negative 1. I've got to include 3x plus 2. That's in those two. I've got to include x minus 5. That's in these two. Here and here. All right, so there's my common denominator. There's nothing else in any, let's not look at these. Nothing else in any of those other ones. So I've got my common denominator. Now I can go through and just write down, like this already has everything except the negative sign. So I'm going to multiply by a negative 1. I'm going to do that as I go along. Negative 1, so negative 2x plus 3. I'll do it in different colors as we go. This one is missing a 3x plus 2. So I have to multiply times 3x plus 2. I kind of ran out of room there. So 3x plus 2, that's what it's missing. So I'm going to distribute that. It's plus 2x times 3x is 6x squared. 2x times 2 is 4x. 1 times 3x is 3x, and 1 times 2 is 2. And our last one, all right, quickly, there. I am missing a negative 1 and an x minus 5. So a negative 1 and an x minus 5. That's what I have to multiply top and bottom by. Now 1 times negative 1 is just negative 1, and when I distribute it in, I get negative x plus 5. All right. Whew, that was quite a bit. Let's continue and see where we get. I'm going to start combining like terms. I've got a 6x squared. Let's see, so I've used that up. I've got negative 2x, positive 4, positive 3, and negative 1. Wow, all right, so negative 2 and negative 1 make negative 3, and 3 is 0, plus 4 is 4x. Then I've got the 3, the 2, and the 5. 3, 2, and 5, that's 10 over negative 1. 3x plus 2, x minus 5. Now, we might be able to do some reducing here, but we might not. We'll have to see how it goes. I can see these all have a 2 in common, so that gives me 3x squared plus 2x plus 5. And then this way. The next thing I can do is try to factor this. I don't know if it'll factor. I'm going to try. So for this to reduce, one of these either has to be 3x plus 2 or x minus 5. Let's see. 3x and x. Well, it's not going to be minus, and it's not going to be plus 2, so it's just not going to work. I could put a 5 in there, but because the signs are both plus, I'm not going to get anything to factor to give me a 2 in the middle. So that's not going to be any good. So I could either stop here or here, but either one of those could be considered your final answer. Whether you stopped here or stopped here. Because it's not going to factor. It's just not. No matter how hard you try, you're not going to be able to get that to factor with integers. Okay, so our final answer. And that's it. So hopefully that helped you, and you know, keep trying. That's all we can ask. Have a great day.